So in this video we'll be looking at the distance between two coordinate points and determining the length between two coordinate points. Now, before we start, let's look at how we write our coordinates. Our coordinates are written like this, okay? X and Y. Cool? So X being our horizontal, right, and Y being our vertical. Horizontal, and Y being our vertical. Sorry, my handwriting is not the best. Right, and then we're going to try and determine the length between these two coordinate points, right? If we have two coordinate points, or the distance. So let me start off with just a basic example, right? So let's just say I have something like this. So we've got x1 and y1. Cool? And we're another coordinate point over here, and we'll just say it's x2 and y2. And we're going to try and come up with some kind of formula or even an equation that helps us find this distance, right? Now, x1 and x2 are two different x values, and y1 and y2 are two different y values. So I'll just draw a straight line through this. I might have to go over my x1 or y1. Okay? So if we think about it just across here, this is our y1. And oops, this over here will be our y2. This is our x1. And this is our x2, right, in our coordinate plane. Now, to determine the distance between two coordinate points, we have to use some different ideas, okay? And we have to probably convert these things into some shapes or use some other aspects or content or maybe a formula from another subtopic, right? So most of you guys would have heard about Pythagoras. Alright, and if you haven't heard about Pythagoras, it will be good to probably go and look at some videos on what Pythagoras is like. And Pythagoras is used for right-angled triangles. Right-angled triangles. What do right-angled triangles look like? Well, they look a bit like this. Alright, and this over here, these two lengths over here, are at 90 degrees to each other. So we look at this and go, well, actually we can probably convert this coordinate distance into a right angle triangle, right? And which I will do over here. So I'll just go right across there. Okay, don't worry if the lines aren't straight. I'm pretty sure this beautiful thing will make it straight for me, which it did. Lovely. And we're trying to find this distance over here, d. Cool. So what we're going to do is we're going to try to determine what this change in x, or this change in horizontal, and the change in y is. So we're going to try and make a formula. We can determine that this over here is y2 minus y1. And we can determine the x difference would be x2 minus x1. Well, this is greater over here, and this is smaller over there. Well, that's y2 over there, that's y1 over there, so we can determine that. Alright? And obviously we use this Pythagoras formula, which is c squared equals a squared plus b squared. So this is a, this is b, this is c. So we'll do the same thing for us. Right? So we'll just try and substitute what we have in this triangle into this little formula over here. Alright, so first things first, well, I'll have to write my c squared as d squared. Alright, and now I'll start off with the a or the b. Well, I'll start with the b first, in terms of the x1. So we'll have x2 minus x1 squared. So we just replace that and square the whole thing. Plus y2 minus y1 squared. Beautiful. We've got some kind of formula coming up. Now, going back to some algebra skills, to get rid of the square root over here, I have to square root this side, and therefore I have to square root the other side as well. Therefore, I will get d on its own over the square root of x2 minus x1 squared plus y2 minus y1 squared. And this is the formula or equation we use to find the distance between two coordinate points. Right, we'll go over a quick example and see how that works. So let's just say we take a coordinate point. I won't draw it on the grid. Let's just take a coordinate point over here. We'll make this 3 and 2. And this coordinate point over here is at -1, -1. Cool, and we're trying to determine this distance. Oh, that line is super ugly. This distance over there. Cool. So let's just go and write our equation out again. I'll do it in a different color over here. So d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And we're going to substitute in our x2's x1 and y2's y1. So over here I'll make this x2 y2 and I'll make this x1 y1. And we'll just go substitute it in. So we get the square root of 3 minus -1. Let's rewrite that again. So -1 squared plus 2 minus, and let's put -1 in there as well, squared. Now, this is where some of your algebra skills or your number skills would come in. So a negative by a negative becomes a positive. So you'll get 3 plus 1 squared plus 2 plus 1 squared. You can now simplify it out. So you get 4 squared plus 3 squared. And you should know this 4 squared becomes, whoops, that ruler shouldn't be there, 16, and 3 squared becomes 9. Therefore you've got the square root of 25. Therefore the distance over here is equal to 5. And you have just determined the distance between these two coordinate points using this lovely formula over here, which you have just come up with using Pythagoras.